Good afternoon. If you don't hear me well, it's because this is not ST microphone. ST microphone is much better. And also the connection maybe can be interrupted. It's not ST radio. So you have a good justification if you don't hear me well. So thanks a lot, Bernd, Giuseppe, Walter. It's really a pleasure for me to be here in the heart of the semiconductor valley, I would say, or island. It's also a pleasure for me to talk about smart cities. Why? I started the MEMS adventure in my professional life talking about MEMS for game. When my wife told my mother-in-law that I was working for games, she told me, "Are you sure this is a safe job? Maybe you should tell your fiancé the time to do something more serious." So I have the opportunity to talk about something where the sensor, the wireless, the semiconductor can do something more useful for the mankind. For sure, the consumer market in the different form, it helped a lot to grow some product that can find application here in the smart cities. So let's go together through this presentation. So why smart cities? I think Bernd already said you an important data point. By 2050, he said, 2 people over 3 will live in a city. I have this another data point, 2030, people saying that 65%. It does not matter. The cities will become more and more the place where we are going to live, or maybe our son are going to live. It's also a place, the cities that are having a big impact on the climate, because you have a big concentration of people in a small space. And then it's also a place where there will be a need of more services, especially for a population that is getting older and older. So the smart city represents, for many players in this industry, semiconductor, system players, data players, a big opportunity for the next future. Today we live in a city. There is a big difference today between a city, I would say, and a town. The town is safer, it's closer to the citizen, it's greener. The cities is not, this is not the place. Also, if you take the most modern cities. So we need to to bring the dimension, the smart dimension, also to something that today is not smart at all. Take the transportation, the infrastructure, the home, the driving, the lighting. What a better infrastructure, existing infrastructure in the city, like the street lighting, to help to make the city smarter and more efficient. This is something that, in my opinion, it's going to happen. We all need this kind of smarter infrastructure. And in this presentation, I will talk about 5 different examples and the related product we are making today to enable this smarter infrastructure. So the smart city is, in my opinion, a way for people to do more with less. There are many different definitions of IoT, Internet of Things. Smart city is one phase of IoT, and IoT for me means nothing more than doing more with less. So we will start to go through these 5 examples in the first part of the presentation. In the second part, I will talk about the different products we, as semiconductor players, are doing for this kind of market segment. So the first one will be the smart street lighting. Think about the smart street lighting. What do we have today in the world? You can read a different market analyst study, and apparently there are around 30 cities in the world that are more or less smart. 30. There is something in Korea, in smaller island like Malta, in a bigger continent like US. What we are doing? There are 3 cities in the world that are using solutions from ST that are embedded in the street light pole. And what do they do? What do they do? They see what's going on. So the applications are different, depends a little bit on the utility. Maybe the colleague from Amsterdam will tell some other interesting application. They're helping to improve, to lower the power consumption because the lighting itself becomes smarter. They're also helping to monitor a little bit better situation so the people in the street feel themselves safer. So there is one city in Europe, one city in Asia, and one city in the US that are using our solution. What do we have inside if you open it? You have a microcontroller, you have sensor, wireless communication. In some cases, the communication goes through the wire line, and some analog component. Example number 1. Example number 2, smart driving. We all say that the next big thing after the smartphone is going to be the car. Some people are defining some electrical car like a big tablet on 4 wheels. So the smart car with all the sensor system to make safer the way we drive, because you are able to detect automatically the car in front of you, because you are able to detect and to understand where to go to park. This is the way the future is going to be. Maybe the car itself will become a service, and you will use a fingerprint to enter your car after you've been paying someone with a security access. So the smart car, here we are working with different players, and we have our system that you see here, the radar system, the GNSS, the ADAS, they are deployed already in several cars on the market. So this is not something that will come. This is something that is already on the market with different players. Then I would like to talk about this smart parking. Also here, it's a combination of different things. It's a combination of different kind of sensors, different kind of semiconductor chips like wireless connection. It's a combination with utility maker, because at the end of the story, the IoT means what? A new revenue stream for people like ST doing system semiconductor, for system maker, as well for utility maker. It's all about a new revenue stream. It's all about creating a new market. It's about what have been happening 15 years ago when the smartphone were not even existing, or the phone itself actually was at the beginning, at the dawn of a new phase. Let's see the example number 4, smart metering. What do we have? Europe is not always advanced in high-tech. That's true. Some other island like Taiwan, some other continent like US are more advanced. But in the smart metering, I think I'm not wrong if we say that Europe has been the leading continent. If you come to Europe, you see a lot of countries where there is a smart electricity meter. And ST has been one of the companies driving the adoption of smart electricity meter way back. It took some time. It took around 15 years to have all smart, to go to the point where we are now, that all the electricity meters are smart. And you can measure at distance. Now what we see happening here, where you have different kind of semiconductor embedded, is the smart gas meter. I want to show you something that we showed actually 2 weeks ago in Japan. What it is? We have a city in Italy with a smart gas meter, where the distance of the gas consumption is done at the reading of the gas consumption is done at a distance. So we have a city where we have the first 60 homes, still small, I agree, but everything starts small, where the 60 homes that are transmitting the data of the gas consumption. The next is going to be water consumption. So what you have here, you have some sensor, gas flow meter, water flow meter, that transmit at a distance this information. Something else interesting, here we are mostly working in California, with companies in California. It's about smart garbage collection. So what we are doing, we are putting some sensor in the garbage collector in a way that the company that is collecting the garbage knows where to go and optimize the path to go to take the garbage. So these are some of the practical examples in a smart city for which we are already working, for which utility makers that are our partner are making money in different ways, for which companies like ST doing semiconductor have the duty to make something that is very low power and an opportunity to increase their sales. So the smart cities obviously need also smart homes. You can have a smart home without a smart city. So in the smart home, you will have, and we see already, different kind of intelligent things. So you have the smart bulb with a presence sensor, or with a Bluetooth Low Energy because you are sitting in front of the TV, you don't want to walk 3 steps to the switch, otherwise you get tired. It's true. Then there are smart appliances that even become what? The hub for other services. I mean, you go around here in China, in Taiwan, in Korea, each one is looking at existing object in the home with different eyes. we are in a situation where I would say we can see the epiphany of a new technology. It means that we can see existing objects with different eyes. And I think this is really an interesting market, an interesting market opportunity we should look at. A washing machine will not be anymore a simple washing machine. It's clear that a company doing washing machine can see that the washing machine is maybe a hub to get some additional information. The same is for a fridge. The meaning itself of the object in the smart home will get confused. They will change. They will not be the same thing that we learned when we were at the school. They will change. So what do you need to make this a smart city? In my opinion, to make smart cities, there are 5 important things. For sure, the place where there are a lot of money is about the big data management. Because you have a lot of sensors all around, a lot of eyes, ears. You are collecting this data, and then what you do? So the company that is able to process all this data, to access the cloud, for sure is making a lot of money. But to make this possible, you need to have some sensor dispersed in the world without wires. So for sure you need a smart sensor. Then we say, what does it mean smart? We say later. Then you see smart actuator, smart energy, and then you may need some smart personal devices. There was a phone, and then it became the smartphone. One of the features of a smartphone is to have a lot of sensors. You remember the first iPhone was the touch sensor. It was making a big difference because the keyboard was not anymore convenient. What we are offering as a company in this field, we are offering different kind of sensors, the most famous MEMS, but also less famous sensors that in any case are important, the touch sensor. You see a city with a lot of buttons, and when it's raining, the button can get clogged. It's much better to have a touch panel. So we are offering different kind of sensors. We are offering also different kind of very low power microcontrollers, very low power analog circuit, because there are sensors that can be done in silicon, and sensors that are not done in silicon will never be done in silicon because they are plastic or other strange material that have no relation with the silicon. Then you have the wireless connection, and then you have the microcontroller. You have to elaborate this signal. What we have been doing in the past 10 years in our company, it has been basically developing the building blocks of this big revolution. It still takes, in my opinion, 2-3 years to see all the players in the industry aligned for this to happen. But it's 10 years, more or less, that we are developing this kind of building blocks. And if we see closer, we had a big, I would say, luck at beginning of 2005, when we started to make money with games. And I had the luck to get in touch with the president and CEO of Nintendo that pushed a lot on the usage of sensor for user interface. You may remember at that time there was Nintendo was struggling against Xbox and against Sony. They were all pushing on multimedia interface, multimedia processing, and this guy said, you know what, I will bet on the user interface. This was a big, big luck for us, because we have been able, basically, to start the MEMS consumerization wave. After that, other guys in the industry have been able to take this technology to put in their product, because someone already debugged it. So it was the case of accelerometer first, 2005, and then it was the year of gyroscope, 2010. Before that period, everyone was telling it was not possible to put a 3-axis gyroscope in a single chip. And then it was the case of a pressure sensor. And then it was the case of microphone. And then it was the case of the touch sensor that you may find a lot in Android phone. I see several of them in this room. And then the case of a new system that we are doing together with Intel for the 3D interface. Before to start with MEMS, I would like to start showing what is, I would say, what has been happening in the last 10 years. We have been put on the market more or less more than 9 billion pieces. 2005, till end of 2005, the number of MEMS we put on the market was peanuts. In 10 years, we put 9 billion devices. Most of them are in consumer and mobile application. The very small percentage is going in these smart appliances or smart street light pole or smart things that are different, because today the bigger market is still there. And we have been basically doing, as I said, different kind. The offer has been expanding, because in this field of the sensor, you cannot be limited only to one sensor, because when you go to talk to a customer, he needs to have more different sensors, and the smart city requires different kind of sensor. One of the sensors, and I'm proud to start with this one, is a touch sensor. We cannot conceive anymore now a mobile phone with a touch, though I have to say I switched from my Nokia phone to Samsung phone only the last week. The touch phone is important. I think in a smart infrastructure, having that we are all used to touch, you take a small child, he goes to the TV to touch the TV to move it. So the touch is going to be natural interface. What we are doing, in this case, we are making the chip that is able to detect this small variation of capacitance. And this is very much linked, if you see from a technological point of view, with what we are doing in motion MEMS. Motion MEMS are the traditional MEMS that ST has been involved in since 2005, accelerometer and gyroscope. Now, which kind of application? We see this application, for example, in structural monitoring. We see, we are working with companies that want to monitor, for example, the situation of a bridge. In some countries, not only in Europe, also in US, bridges are falling down. It may happen. Not only actually in Europe, also in Asia it happens. So by usage of this kind of sensors, you can understand the status, the structural integrity of this infrastructure. In this specific case is a bridge. What we are doing here, we are doing different kind of accelerometer, different kind of gyroscope. The main driver so far is still the consumer, the mobile phone, but we see a lot of interesting requests and applications from customers that are looking in this smart city world, smart home world. And when you talk about these things, there is one important parameter that is important: accuracy. Accuracy, when you do smart sensor for the smart city, is fundamental. Is more important than other things that are, let me say, important in the consumer mobile phone. So we, as a semiconductor player, are addressing this need, and we have to do more and more an optimization of the sensor in this respect. Then there is the microphone. The microphone is an interesting device. We see more and more picking up in the smart city. The street light pole example I was telling you before, there are several microphones. The microphone also has some features that you can embed in to protect the privacy, because it's not nice that you have this big brother all around that is monitoring everything. You can make the microphone in a way that you can guarantee the safety, the security, and the people can walk safer in the city without listening too much to what they say. In the microphone here, I put what has been the evolution of ST in the last 3 years. In 2012, we were doing a few million pieces. In 2014, we shipped more than, I would say, 5 million a week. In 2015, we expect to double this number. What is the driver? The driver is, again, high-performance microphone. So this microphone field is something that we see having different application, even in the cross-light. The volumes of a cross-light, sure, they are different from a smartphone. Not so many of us are going with the cross-light on the shoulder. But this is an application where we see more and more the microphone getting in. Another field of sensor, another kind of sensor that we see more and more embedded in this infrastructure is environmental sensor. So we talk about humidity sensor, about pressure sensor, about UV sensor. These are sensors for which we see an application in these kind of things. What you have to do here, the main driver is to increase accuracy and to make them compatible with harsh environment. And then I want to put you this one of the recent announcements we did together with a partner. So smart home or smart building. Today, you need a key to enter in it. Unless you are at FBI or CIA or some other governative agencies that are able to recognize the face and the fingerprint, you still need a key. And you trust the key I renovated recently the house. I did not put any fingerprint. I still have a good old Italian key. Now, if you want to do the fingerprint sometimes is not enough. You want to have also face recognition. And when you talk about face recognition, iris recognition, you need different kind of technologies. So you can combine the two signals together. You can enter your house, let's say, in a safer way. And you don't want anyone else to enter your house. So what there is here? There is a technology that we developed together with Intel that is already on 8 PC manufactured here in Taiwan. What is about? On top of the screen, close to the camera that you are using for Skype or whatever, there is an infrared laser that is basically scanning the scene in front of you and measuring the deformation of this scene. You understand what's happening. So you can measure the 3D picture of object in front of you, and you can even go down to recognize the face of the people. So I put this technology here because this technology can find application in the smart city. It can find application in the smart car. Do you believe in 2020? Or maybe I want to take some margin, some risk margin. In 2025, we will still have all that things, a button or whatever in front of us in the car. Don't you believe we will have a nice head-up display projecting on the screen this information so when we drive, we can drive safely because we don't have to distract ourselves to push a button here and there. So head-up display, I believe is going to happen for the smart car. Some companies, let me say, have already it. And with this technology, you can have a better user interface. Mobile cinema at home. There was a time there was the mobile phone, the fixed phone at home, and then it came the cordless. The same, I think, is going to happen with mobile projector. I don't know what's happening with this. I told you, this is not ST radio. This is someone else's radio. Maybe some supplier is here. Don't get offended. It keeps changing. So image projection, sorry, and then the head-up display. What you need? You need some mirrors that are done in MEMS. So this kind of technology can find a different application, and we start to see the beginning. We are seeing this technology entering the consumer, the computer. The next one is going to be, for sure, the head-up display and the mobile cinema at home. When you do, I said, IoT, it's not all about sensor. It's also about some brain that are able to take this information, to put them all together, and to give some meaning. And for this, you need microcontroller. We selected a few years back, 8 years back, ARM platform. And also here, I think we had some luck that ARM processor has become the mainstream. So we have a full-fledged family of microcontrollers that we put inside different IoT objects in the smart cities, but also around the body, to process the signal that is coming from the sensor. On top of this, we have also, as I said, wireless connection, either for short range, Bluetooth Low Energy, or for longer range. In the street light pole, you don't have the Bluetooth Low Energy 2.4 gig. You have the sub-gigahertz radio because you have to transmit the data at a longer distance. And we are able to work. We are working with some partners to make a mesh network. So we have a radio for short range and for longer range, but we have also some analog components that are the interface of sensors that are not necessarily done with MEMS technology. So these kind of building blocks are fundamental to enhance and to enable this new application. Now, there is also another important point, where the innovation in the smart city is coming from. I think that more and more this innovation will come, in my opinion, not from big companies, from startups. Think about the objects that are smart and that are developed by small companies, startups. There are a lot of them. They are using the sales channel, distribution channel of bigger companies. But think about, mention some of Netatmo. It's a company based in Paris that is putting the kind of weather station. They are using Apple distribution stores, but this is coming from a company, maybe there are 10 of them. So what I want to say is that we, as a semiconductor player, have a big responsibility. We have to make sure that this engineer, this employee, this startup maker, entrepreneur, have the access to these building blocks in a way that can go fast to the product. I have worked in the last 2 years with a lot of companies. Someone is thinking to do a smart shower. To do what? To save water. There is a project in France where it is demonstrated that by putting a some sensor, some kind of intelligence in the shower, you can save more or less 50% of your bill in the water consumption. This is true, it's not a joke. There are big companies beyond this. You can go to Leroy Merlin or whatever. Maybe there is no Leroy Merlin here. But you can find this. So it's about making the things smarter. We have the responsibility to give the tool to the people to make sure that they can develop these things. So what we are giving? We are giving simple hardware to connect, like when you're playing Lego. And we are also giving them some open software. Because when you have an open software, the people can easily connect the building block and don't waste time to connect the things. We want people with new ideas to spend their time to optimize the application, not spending their time how to connect different blocks. We have a program that is available now through the web, where you have all the blocks are there. For sure, you need to have the killer application, the killer idea. Otherwise, I mean, the killer application is not in this software that we are providing you. This must be the fundamental basis of the startup, of the company. But we are, I think, lowering the entry barrier for you to enter in this field. So I would like to put a final chart with the key takeaways. I think number one, the consumer and mobile phone market did something important in the last 10 years. They helped the companies like ST and others to miniaturize sensor technologies at an affordable price in a way that they can be available for something like a smart city, with smart parking, smart infrastructure. 10 years ago, thinking about, there were not big players doing sensor. There were some companies that were doing sensor mostly for automotive, but the requirements for automotive were different. I think that in the last 10 years, the consumer mobile phone market pushed the semiconductor maker, like ST, to miniaturize sensor, and now at this point, the sensors are there, available for new ideas for engineers with their own ideas of startup. So the market, this market was instrumental to the smart city, to the IoT, and I think that in this way, with the sensor, we really can do more with less. We, ST, have a portfolio that has different blocks. We are going from analog to RF to sensor to microcontroller. We are working with different partners, and we are doing our best to put available these blocks on the web, either hardware or software, and we are here, and also one of the reasons why I liked a lot the invitation of Bernd, Giuseppe, and Walter was to come in a place, in an island, that is very vivid, of brilliant ideas. So I would be more than glad to start a new cooperation with people in this room to see how we can make smarter a city, how we can make another big change in the semiconductor together. Thanks a lot for your attention. I leave the stage to the next speaker.